Hello everyone. In this video we will continue with the fourth ventricle. So next we are going to learn about the roof of the fourth ventricle. The roof of the ventricle is again diamond shaped and it can be divided into the superior part and the inferior part. The superior or the cranial part of the roof, it is formed by the superior cerebellar peduncles and the superior medullary velum. Superior medullary velum, it is the thin transparent lamina of the white matter which stretches between the superior cerebellar peduncles that you can see in the diagram, right? The superior cerebellar peduncles, on emerging from the central white matter of the cerebellum, pass first cranially and ventrally, forming at first lateral boundaries of the ventricles. On approaching the inferior colliculi, they converge and then intermingle over the ventricle and forms the part of the roof, right? We have seen that the superior cerebellar peduncles, it was forming the part of the lateral boundary, and now it is also forming the part of the roof, right? So you will get the answer here. The superior medullary velum, it fills the angular interval between the superior cerebellar peduncles. It is covered on the dorsal surface by the lingula of the superior vermis. The caudal or the inferior part of the roof, right, here you can see, in most of its extent, it consists of an exceedingly thin sheet entirely devoid of the nervous tissue and formed by the ventricular ependyma and double fold of the pia mater or the tela choroidea of the fourth ventricle, which covers it posteriorly, right? So lower part of the inferior part of the roof, right, it is formed by the tela choroidea of the fourth ventricle. Caudally, the continuity of the sheet is broken by a gap termed as the median aperture, through which the cavity of the ventricle communicates freely with the subarachnoid space in the region of the cerebellomedullary cistern. The inferior medullary velum forms the small part of the roof in the region lateral to the nodule of the cerebellum. Here, you can see this is the flocculonodular lobe, right? So in this region, the inferior medullary velum will form a small part in the roof. Superior to the region to the inferior medullary velum, on each side, the layer of the tela choroidea in contact with the ependyma of the caudal part of the roof reaches the inferolateral boundary of the ventricular floor, which is marked by the narrow white ridge that is termed as tinea. The two tinea are continuous below with a small curved margin, the obex, often used to denote the inferior angle itself, right? So here we can see this in the above diagram, in the floor itself. Here you can see the tinea is shown, see, right? This is the tinea, and here you can see the obex, right? That is the inferior angle of the fourth ventricle, right? And this ependyma and tela choroidea, right, together they will form a white ridge that is called as the tinea, and both sides tinea, they will converge and form the obex, right? Next we will learn about the tela choroidea of the fourth ventricle. That is also very important. Yes. Now in this diagram you will be able to see the tela choroidea is shown here, right? It is a double layer of the pia mater which occupies the interval between the cerebellum and the lower part of the ventricle. Its posterior layer provides a covering of the pia mater to the inferior vermis, and after covering the nodule is reflected ventrally and caudally in immediate contact with the ependyma. The tela choroidea with the vascular fringes covered by the secretory ependyma forms the choroid plexus of the fourth ventricle, right, from which the CSF is secreted. This projects into the lower part of the roof of the fourth ventricle. Each plexus, right or left, consists of a vertical limb lying next to the midline, right? This we can see in the above diagram. Here you can see this, there is a vertical limb and there is a horizontal limb, right? So this, both the sides vertical limb together, right, and this horizontal limb, right, it is giving an image of letter T, right? They are forming a T-shaped image, right? So each plexus, right or left, consists of a vertical limb lying next to the midline, right? This is the vertical limb, and horizontal limb extending into the lateral recess. The vertical limb of the two plexus lies side by side so that the whole structure is T-shaped. The vertical limbs of the T-shaped structure reach the median aperture and project into the subarachnoid space through it. The lateral ends of the horizontal limbs reach the lateral apertures. Here you can see the lateral recess and the aperture. The arterial supply of this plexus is from the posterior inferior cerebellar arteries, right? This is important to know, that the arterial supply of the plexus is from the posterior inferior cerebellar arteries. Okay, so that is all about the floor of the that is all about the roof of the fourth ventricle. Next we will see the communications of the fourth ventricle. For that we will see one more diagram. Okay. In this diagram you can easily see superiorly, here is the fourth ventricle, right? Superiorly, where it is communicating to the third ventricle through the cerebral aqueduct, right? Inferiorly, it is communicating with the central canal of the spinal cord, right? With the central canal of the medulla and then to the spinal cord. Dorsally, in the lower part of the roof, right, there is a median aperture. Just now in the diagram of the roof we have seen the median aperture, that is also called as foramen of Magendie, right? That median aperture is called as foramen of Magendie, and through it the ventricle communicates with the subarachnoid space. Here is that aperture you can see, right? Through here it will communicate with the subarachnoid space, that is to the cisterna magna. On either side again it communicates with the subarachnoid space only through the lateral apertures, that is the foramina of Luschkas, right? Here you can see, if we can see, this is the fourth ventricle. Both the sides you will find the lateral aperture, that is the foramen of Luschkas. Through that Luschkas, through the foramen of Luschka, again it will communicate with the subarachnoid space, right? So these are the four communications of the fourth ventricle that you should know. Next is the recesses of the fourth ventricle. Recesses are nothing but the extra spaces that you can see, right? Boundaries, except from the boundaries, the other spaces that you see of the fourth ventricle, that are the recesses of the fourth ventricle. So here you can see there are total 5 recesses, right? The first one that you can see in the middle part, that is the median dorsal recess. It extends into the white core of the cerebellum above the nodule, right? The 2 lateral dorsal recess, one on each side, extends backwards, lying above the inferior medullary velum and below the cerebellar nuclei. And the 2 lateral recesses that you see here, one on each side again, extends laterally between the inferior cerebellar peduncles in the front and the stem of the flocculus behind, and they reach up to flocculus itself, right? Each recess opens at its lateral end through the foramina of Luschkas, right? Here they have shown the lateral aperture as well. You can see the foramina of Luschkas, right? So these are the 5 recesses. One is the median dorsal recess, 2 lateral dorsal recess, and 2 lateral recesses, right? Total 5 recesses you have to remember. The last part is the clinical anatomy, right? Here you can see the clinical anatomy of the fourth ventricle. only 2 points you have to remember here is, first is the vital centers, they are situated in the vicinity of the vagal triangle, right? That we know that in the vagal triangle we have seen the vagal nuclei is present, and you know the function of the vagus nerve, right? So it is a very vital center, and injury to this center, right, or this area, it would be prove very fatal. Infratentorial brain tumors, they block the foramina of Luschka and Magendie situated in the roof of the fourth ventricle. This results in the marked early rise of the intracranial pressure, which causes headache, vomiting and papilloedema, right? We know that the foramina of the Luschkas and Magendie, through this foramina, the fourth ventricle communicates with the subarachnoid spaces, and if this are blocked through the tumors or any other reason, then there will be a rise in the intracranial pressure, which will lead to the symptoms of headache, vomiting, papilloedema, etc. Right? So again, this infratentorial brain tumors, they can prove fatal for the human life. So these are the two applied anatomies of the fourth ventricle. Okay, we complete with the fourth ventricle here. Bye for now.